Okay, so we're going to look at factorising z squared plus 6z plus 13. All right, and as we mentioned before, if it's got z to the power of 2, then we should have two solutions for the root, or we should be able to factorise it in terms of two linear expressions. Okay, so my first step in this situation is going to be to complete the square. So I've got z squared plus 6z, and I know that if I want to complete the square, I'll need to add on half of this squared. Okay, so I'll need plus 3 squared to complete the square. Now if I've added 3 squared, I've got to take away 3 squared. And then I've got the plus 13, so I add the plus 13 at the end. Right, now this part here is the square completed. So it'll be equal to z, so we've got plus, it's plus 3 here, squared. And I've got take away 9 plus 13. So take away 9 plus 13 is the same as take away, or sorry, plus 4 it is. Right. Now, again, I've got the situation where I've got this plus 4, which could be written as plus 2 squared. Now, because I've got plus, I'm going to use the same idea as in one of the previous examples I did, where I'm going to take away, I'll take away 2i squared. Now you can see if I have I squared is negative 1. And then negative times negative gives us our positive, and then 2 squared gives us the 4. So it's exactly equal to the above line. But now I've got it written such as the difference of 2 squares. And now I can continue to factorise. So I'll have z plus 3 in brackets, take away 2i, close brackets, z plus 3 again, plus 2i in this situation, because I've got the difference of those 2 squares. All right, and then that is this expression factorised in terms of two linear expressions. And if I wanted to work out the roots for this, I'd make the other side equal to 0, and then using the null factor law solve for z. Okay. Hope that helps. Thanks, guys.